You can calculate something else based on your um, formulas that you would need. So let's go ahead and calculate the turns ratio. Reading the question, it says the power transformer in figure 2 has 14,560 volts applied to its primary. So automatically, once they say that, they are telling you that EP is equal to 14,560 volts. So when you're doing this question yourself, these are the things that you are going to do. You can go ahead and underline this key information. You can write on the top of it what it stands for. All right? And then you move on and it says the secondary voltage. So automatically, if they say that, automatically, this 200 volt and 8 volts is your secondary voltage. You know that is EF. And then it says the load is drawing 210 amperes. So now you say to yourself, the key word here is load, and you look on your diagram and you remember that the purpose of the primary coil is to supply the transformer with the input. So the primary side is input and the secondary side is output. Now, another way to understand it is the output side is the side that uses the voltage. The input side is the side that supplies. The input side is the side that supplies. So if for example, you are charging your cellular phone, the part of the charger that plugs into your cell phone would be the output part, right? So your cell phone would be the load. The part of the charger that plugs into the wall would be the supply part, which would be the input where you get the voltage from. And between the input and the output lie the transformer coil. The input into your cell phone charger is 110 volts. And the output to your phone is about 5 volts. So the transformer does its job breaking down, or what we call stepping down, the voltage. Transformer steps down or steps up voltage and current in a circuit. Okay? So when you read this and you see the load is drawing 210 amperes, automatically you recognize that this 210 amperes here represents what we now call IS, or secondary current. All right? Now, finding your turns ratio. Turns ratio, which is TR. And we are looking now at which formula has two things in it. And automatically we recognize that it is our voltage formula that has two things in it. So to find that now, we are going to say TR is equal to EP divided by Yes. Input in the values. EP is 14,560 divided by 208, which is EF. Everybody with me?
Mm-hmm.
So when we divide that, how much do we get?
Hold on.
You should get 70. Now, since that is
4,000.
70, right?
Yeah.
Now, since that is 70, we must represent this as a ratio. So we'll put the colon and put 1. What this means is that for every 70 turns on your primary coil, you turn 1 turn on your secondary coil. Okay? So now we have found our turns ratio. Very important. The next thing says calculate. Part A says calculate your primary current, which is what we are going to do now. Seeing that we have our turns ratio, we only need secondary current to find primary current. So we will now use the formula turns ratio is equal to current secondary divided by current primary. We already have our turns ratio as 70 to 1, which means we can write this ratio as a fraction as 70 over 1. And we will now put our secondary value in, which is 208 divided by our primary, which we don't know. So if we were to cross multiply, right? If we were to cross multiply because we want to get IP by itself, when we cross multiply and transpose, I'm fast forwarding, to get IP by itself, we will have IP is equal to 208 divided by 70. Let me see if you all caught that. You all see how that transposes to get that. Huh?
Yeah.
Zoe?
Yeah, you can hear me?
You got it right?
Yes, sir.
I know Tamia got that. Good.
I had to wait because you was playing music. Yes, wait. You was blaming me for the music?
All right.
Yes. I was in the bathroom. No, but when you need to come out of the bathroom, the music was still playing.
Anyway, let's go. So 208 divided by 70 should give us 3 ampere. Okay? So that's how you would calculate IP. 3 ampere. The next question asks the resistance of the load. Now, to find resistance, we have to go back to a formula that utilizes 2 quantities that we already have in this equation. And the 2 quantities that we already have in this equation is voltage. We also have current, and we are looking for resistance. All right? So if we cover resistance, we realize that excuse me, the resistance of the load, we would call this RL. I need a small L. Anyway, R resistance load would be equal to voltage on the secondary now, because the load is on the secondary, so we have to say ES divided by the current on the secondary, which is IS. Okay? We already calculated, not calculated, we know from the question what IS is and what ES is, so we can just simply go ahead and plug values in. ES is 208. We'll divide that by 210. And we should get something like, 0.98 something, 81 or 9, 0.99 or something like that. And we'll put the omega value on it. All right? And part C asks us to find the power the load dissipates in kilowatts. To calculate power, we again go back to our familiar power triangle. We put P on top. We have I. And we have E. So again, we're on the load side. So and I'm going to go on this side. We're on the load side. So P will be equal to voltage secondary ES times IS. And that will be 208 times 210. And how much that is? Calculate that quick for me.
Ah?
Here you go.
How much that is,
Oh,
guys?
I didn't see it.
208 times 210.
43,680.
43,680.
43,680. 680.
All right, 43.
First of all, your calculator dead.
Did you turn it on?
Yes, it did.
43,680. Okay, now this now is given in watts. We must now change this to kilowatts, which will be what?
Kilowatts, yeah.
40.
You change the kilowatt? Hold on. Don't.
Yeah.
The kilowatt, that'll be like.
Pass me the next
That'll be 43 point something. Hold on.
43.68.
You was fall.
Six, yeah.
43.68.
680.
You wouldn't put.
Hold on, Spence. Watts bigger than kilowatts?
No, watt is the unit, is the base unit. Kilowatt is larger, but the value is going to be smaller. It's going to be represented
Okay.
smaller.
What do you teach electrical plumbing?
Electrical installation.
Oh my
What?
God,
Electrical installation.
So you teach how to like create electricity.
All right, so you could mute that.
I really hope he didn't hear you, babe.
All right.
Sorry,
So
sorry.
all of this on my recording, just so you know. Tamia, you still with us? Because I